Evolution of Technology, a presentation on the technology of rapid prototyping. This presentation is the midterm assignment for TMC 431, Innovation Technology, by Robert Kavanagh and David Soto. Prototyping is an activity in which one tries to demonstrate a product or system before it is finalized. A design of the final system is built or drawn in a smaller scale before the final concept is completed. In its prototype stage, the product does not necessarily need to be fully functional. Its purpose is to show concept. Being able to do this many times results in ample savings as it saves in resources and time. The use of prototyping for pre-production product testing before it is fully engineered has become a popular practice. Changes based on the different iterations of the prototype allow entrepreneurs to make changes in a cost-effective way before creating product for volume production. When done correctly, prototyping can result in a more efficient and precise design of the final product. Rapid prototyping is the use of computer-generated three-dimensional models that are created using a form of CAD drawing. One of the defining characteristics of man is our curious nature. Prototyping is as old as the advent of modern man. Early cave drawings and artifacts show that our ancestors utilized the technique of prototyping to outline the process of larger buildings and product builds. The Parthenon Temple on the Acropolis in Athens, Greece, was constructed in 447 BC. Historians believe that this monument was built to honor the goddess Athena. Like many structures of this era, the Parthenon was first constructed utilizing wooden prototypes that allowed the Greeks to carry a small miniature reference model to the construction site. Prototyping created a gain in this case by making certain that the completed design was agreed upon in smaller scale before the full-scale final product. Although miniature prototyping is very cost-effective, it is not always the only way. In building the Colosseum, the Romans had large-scale prototypes in the form of the Egyptian and Greek ruins to draw experience from. They were able to visit these great structures and utilize them as prototype subjects to build their knowledge upon building the superior architecture of the Colosseum in Rome, Italy. At one time, it was common practice to generate and submit a working prototype to the U.S. Patent Office when filing for a patent. Although creating prototypes is an overall savings as opposed to building a fully functional model, it can be a costly process. Entrepreneurs do not need to patent every iteration of their prototype phase. A prototype is no longer required prior to filing a patent application with the U.S. Patent Office. Prototyping has evolved greatly from the wooden pegs used by the early Greeks compared to today's rapid prototyping technology. There are a few conventional methods that are widely used today, from conventional machining to the now variations of 3D printing. Conventional machining has advantages that you can produce a very similar prototype in mass and that are similar to the desired final product. Its disadvantage is that many times these prototypes are carved out of blocks of material, making the process very wasteful. Stereolithography utilizes curable polymer resins to build layered prototypes. Its advantage is its speed and accuracy. The disadvantage of stereolithography is the size of the prototypes are typically very small and considerably more brittle than other processes. Selective laser sintering is similar to stereolithography, but it utilizes a wide range of materials as it can be utilized with plastics, metals, and ceramic powders. Selective laser sintering produces strong prototypes, but its accuracy is its weakness. 3D printing is a very popular prototyping technique that also uses an additive process. An object is created by laying down successive layers of material until the final product is created. It has a similar size and constraints as stereolithography, but has much better accuracy. The material choices are relatively limited. Vacuum casting is a vastly different process than utilizes silicone molds. The molds are utilized to create parts. This produces a high accurate quality but cost of producing the molds is high. In the late 1960s, Herbert Volcker pioneered the modern prototyping era when he conceptualized the use of computer-controlled machinery. This technology was starting to be utilized in factories. Volcker was the first to conceive the idea utilizing computer-generated instructions that would feed information to the machineries to produce parts based on software. Volcker developed the basic mathematical algorithms that defined early three-dimensional modeling. Volcker's prototyping theories started to redefine design methods. In the 70s, although the old methodologies were still widely used, most companies were still utilizing the tried and true method of machine tooling out of chunks of metal to carve out prototypes. The credit for developing the technology of rapid prototyping goes to Chuck Hull. Hull is considered the father of rapid prototyping. In 1983, Hull was working for a small company that used a UV light sensitive material to create a hard and durable finish on furniture. This material, known as a photopolymer, was applied as a liquid and when exposed to UV light, instantly became solid. Hull realized that with using this material, a process could be developed that would apply and expose multiple thin layers in order to create a 3D object made of solid plastic. After several months of development in a small lab in his home, he ended up with a working prototype of his machine. The process that Chuck Hull had developed is known today as stereolithography. In 1986, Hull co-founded a company called 3D Systems, where he still holds the position of Chief Technology Officer. Today, 3D Systems is one of the leaders in driving what is known as additive manufacturing technology. Early on in the rapid prototyping industry, very few companies had the ability to utilize the newly created technology. This was due not only to the price of the machines, which were extremely expensive at the time, but the infrastructure. The supporting technologies to make this a viable product were far behind. First and foremost was the technology of 3D computer-aided design. Computer-aided design, or CAD programs that were capable of creating virtual 3D models, were just emerging. Most of these programs utilized massive computer systems to run all the algorithms required to do the virtual modeling required by the new technology. It wasn't until the mid-1990s that companies like Autodesk, Dassault Systems, and Pro Engineer developed parametric design tools that could run on a personal computer. These parametric design tools gave almost any company the ability to generate the required virtual models needed to utilize this growing technology. Today, there are many low-cost to no-cost virtual CAD programs available to anyone who wants to venture into creating their own virtual models. The introduction of parametric design tools opened rapid prototype technology to many, but it was still a fairly expensive venture. In 2005, an open source version of the technology was developed at MIT. This was the spark that ignited the industry. All the components were in place and the industry took off. Versions of the technology were finally inexpensive enough for inventors, hobbyists, artists, or anyone else to experiment. Today, for as little as $1,000, a person can have a very basic fused deposition modeling machine in their own home. What started out as a new way to quickly create a prototype for developing a product is rapidly finding its way into mainstream manufacturing. Advances in the technologies, as well as expanding catalogs of materials, have engineers rethinking the way they design. Design is no longer bound by conventional manufacturing practices. Products can be developed that are impossible to build using conventional methods. The automotive industry is developing components that are lighter, stronger, and more complex to meet the next generation of efficient automobiles. Aerospace is developing lighter and stronger components for their next generation engines and lighter weight aircraft. The medical industry is using these technologies to create more natural joints for joint replacement. The industry is using the technology to create prosthetic limbs. Synthetic and natural skin grafts can be printed, as well as bone implants and even replacement organs by variations of this technology. The prototyping customer is looking for a way to create a conceptual functional model of their concept. This model will help verify the functionality of their product as well as work to help sell the concept to potential customers and investors. The pains of the prototyping process involve primarily the cost of the model as well as the time to produce it. The gains that rapid prototyping offers is the speed at which the iterations can be produced and the reduction of costs from producing a prototype by conventional or subtractive machining methods. What could take days to produce using conventional machining methods takes only hours by rapid prototyping, additive manufacturing methods. A technology that was conceived over 30 years ago is just now beginning to find its potential. There are great strides being made in developing new systems that use a larger variety of materials. There will come a time when industry will have the ability to replace a broken part with one that has been printed. Printed circuit boards and complex electronics will be printed, drastically reducing their costs. The ability to replace human organs with ones that were printed is a real possibility. The applications are endless. If we can imagine it, we can create it. This concludes the presentation. Thank you.